Okay, this is 5.5b, elementary algebra, still working on the sum and differences of two cubes. So I put both formulas up there, and let's jump to example 6, where we have a cubed minus 1 over 8. So remember, we're trying to put a cube on each one of these. I don't have one on the second one, so we're going to have to make one. So a cubed minus 1 over what number times itself 3 times will give us 8. 2 times 2 times 2. So I can write it that way. Okay? So once I write it that way, remember, all I have to do is take off the cube sign. Oops, I don't know why I keep putting an equal sign. That's a minus 1/2. So that's my a, and that's my b. So because it's a difference of two cubes, I'm going to use this formula right there. So using this formula, my first term minus my second one, my first term squared, my first and second multiplied, so I can go 1/2 a, and then my second term, I'm going to square it. Okay, so I took 1/2 times 1/2, multiply the numerators, multiply the denominators, and that's where the 1/4 came from. Alright, and I'm done. Alright, let's look at, see if I can get rid of some of this without erasing my formulas. Alright, let's look at one where we're adding, which is example 7. X to the 6th minus y to the 6th. Okay, so how the heck do I make that a cubed? This is where it gets a little tricky, but I have to take and divide that by 3 and that by 3 because it's a cube. And what do I get when I take x divided by, or 6 divided by 3? I get a 2. And I get a 2 there. So this is what I'm going to look at, because this is actually, if you want the gist of it, so I've got my cubes up there. So remember, 6 divided by 3 is 2. So I put my 2 there and my 3 there. Those two multiplied give me my 6 back. Those two multiplied give me my 6 back. So the way I find the cubed is I divide it by 3, and that gives me x squared cubed. If I wanted to find the squared, I'd divide it by 2. Okay, so anyway, I'm trying to get my cubed here. So if you're looking for a 3 up there, you divide that into 6, and that gives you this number. So this is what I'm looking at. So I'm going to take x minus y. I'm going to use this formula here. Take my first number minus my second number. Take my first number and square it. X squared times x squared is x to the 2 plus 2, which is 4. Plus, it says multiply those two together. X squared, y squared, plus this squared. Y squared times y squared equals y to the 2 plus 2. Remember, when you multiply exponents, you add them. And I am done. So I'm not going to go into any of the problem sets here because they're pretty much exactly like what we've been doing, but I do want to look at a couple just to bring up. When we get to one like 37 or 39 or 41, they do it a little bit different. I don't like the way they do it. I think it's a lot messier, but you will get a different answer than the book does, and that's okay, because what the book is doing is it's going back. Let's look at number 37. Okay, remember I said we're going to write it like this. And this is like the last one that we did, because now that's the difference of two cubes. So we've got a squared minus b squared is all we're looking at, and then we're going to look at this formula right there and plug the a squared in for a and the b squared in for b and solve it. Well, what the book is saying is that you could also, well, let's write it. We could write it this way. Or we could switch them around. Because notice they both are 3 times 2 is 6. So if we do it this way, we have the difference of 2 squares instead of the difference of 2 cubes. Well, that's not what the lesson is teaching. It's the difference of 2 squares. So even though they're going to give the answer in the difference of 2 squares from the last section, I'm saying let's just stick with this. So the book will have an answer that's different than you do because they are using this kind of the formula, which you probably don't understand what I just said, but that's okay. Alright, so that's it for lesson 5.6.